So when we did congruent triangles, we have theorems and postulates like side, 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 angle, angle,
Proofs.
angle, side, and HL, right? No, we're not doing proofs. So we have those same kind of theorems and postulates with similarity. There is an angle, a side, and a side, side similarity. Okay, so postulates and theorems. Angle, triangle, similarity postulate. If two angles are congruent in a triangle, then the triangle is similar. So if you have two triangles, oh, that wouldn't be 50. Yeah, it would. Okay, first of all, look at this up here. How do I know two angles are congruent here? How many degrees are in a triangle? So 70 plus 60 is 130, plus 50 more is 180, right? So this one here is 50. So do you guys see how there's two congruent angles in this triangle? If you have two congruent angles in a triangle, doesn't it force the third one to be similar? Because they both have to add to 180, right? So doesn't this force this one here to be 60 as well? Because 70 plus 50 is 1/3. No, 70 plus 50 is 120, right? You're confused, right? Are you confused? Okay, so think about it. Don't write on this just because I'm saying it. All right, so if you have a triangle, and you know these are not drawn to scale, and you know they're both 30 and 50, doesn't it force this angle also to be congruent?
Yeah.
Right, because these are both 80, which means these both have to be 100. So what I'm saying is that's why you only need to know two are congruent, because the third one will automatically be congruent as well because of that.
Like, how do you know the other two measurements? Like, how would you know?
It will give you two measurements in the triangle from the beginning. So if you find all three measurements in your triangle and they're all three the same, then you have an angle similarity. Okay?
Thank you.
Yep. Side similarity theorem. That does not mean all of the sides are congruent. It means all of the sides are proportional. You know how we've been setting up those ratios and proportions? So that's what that's saying. So it's saying if three sides of the triangle are proportional, meaning they simplify to the same scale factor, then the triangles are similar. So for example here, what I'm saying you have to do, if this is triangle ABC, and we're trying to make it similar to triangle DEF, we need to say that AB over DE equals AC over DF, which equals BC over EF. That's what I'm saying by proportional. So you set up that ratio and make sure that they all simplify to be the same exact scale factor. You're fine. Don't worry. So side angle side triangle similarity theorem says if two of the sides are proportional and the included angle is congruent, then the triangles are similar. So what this is saying here is if I draw those triangles again, so if I know that this angle is between these sides, so do you guys see how the angle is the included angle because the two sides form the angle, right? So you see how AB and AC form that angle and ED and DF form that angle? Then you have similarity. So if you know that the angles are congruent, so angle A is congruent to angle D, and if you set up the proportions and you have AB over DE equal to AC over BF. Then you have side angle side similarity. And this is how I write them. When I write them down, I write it as AA and then I put a similar symbol after it because it means similar. And for side, 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 I do side, 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 and then I put a similarity thing after it. For side angle side, I'll do side angle side similarity. The reason I write it that way is because there's side, 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 and side angle side congruence theorems. So that's the way it allows me to differentiate between the two. Okay? So let's put this to work. Let's see how you guys do with it. Your test will be, so you have a quiz Friday, and then your test will be the following Friday. So we're not going to have much time to study for your final at all. Yeah, I know. So if you need me, come see me. Okay, are the triangles similar? Why or why not? So remember, you need to use angle-angle similarity, side-angle side similarity. Uh-oh, why is it all of a sudden having issues? So we have angle-angle similarity, side-angle-side similarity, and side-side-side similarity that we're going to be using to prove these. So we have to use those for our why or why not, okay? So, are these two triangles similar? Are 4, 5, and 8, 10 similar? Do we know that two angles are congruent? Do we know anything about two angles being congruent here? No, we do not. They are not marked. Do we have side, angle, side? Do we have two sides and an included angle? We have two sides, right? Is the included angle marked, though? Do we have three sides marked? No, so there's not enough information. So we're going to say not enough information. No. Although I wish, right? Okay, B is below it. These should be marked like this. Can you add a double marking on these ones? Okay. If sides, then angles. So if this one is 50, what is this one? 50, which forces this top angle to be 80, right? So if this is congruent to this, that means that's 6. If 12 is congruent to this side, that means that side is also. Okay, so do we have two angles? Could we? Don't we know these two should be congruent, right? So what would those two measures be? So this could be similar by angle, angle, similar. So that's the first way. It also could be similar by side, angle, side. Do you see side, angle, side here? And we'll talk about why. So side, angle, side similarity. They both have angles that are 80 degrees, and our sides are 6 over 12 and 6 over 12, which is 1/2. So do you see how the angles are congruent and the sides are in proportion? So you could do either one of those, depending on which one you see. Okay, C. If this is 90 and this is 44, what would angle B be? You raising your hand, Landon? Okay, what would angle B? What is it, Melinda?
46.
46, okay. So what would angle D be?
46.
Let's try again.
44.
How about you actually try to add them together instead of just taking guesses? We don't know if it is or not. That's what we're trying to decide. 43? Did anybody else get 43? All right. Are these triangles similar by angle, angle? Do we have two angles congruent?
Yeah.
No. We only have one. The other ones are not matched to another one, right? Do we know any sides? Do we know any sides? No, so is there enough information here? Actually, there's enough information to say not similar. The angles are not all congruent. So not similar. Angles are not all congruent. Oh, what did I just do? You don't even see that, but this is what's going on my paper, so I have no clue what I did. Okay. Do you guys have questions on that one? Do you guys have questions on that one? I don't know what just happened.
Angles are not
I got 59.
Did you get 50 this time or no?
Yeah. But
Okay, the first time you don't know how you
Yeah.
got it. So if it's side angle side similar, guys, I know, hey, this is like one of the most important topics, so if you don't get this, this is going to be a huge issue. So if we're doing side angle side similar, 4 over 8 and 5 over 10, 4 over 8 equals 5 over 10. That is true because they both equal 1 over 2. Okay? So you guys see that there. Anybody confused on that one? Yes.
Can you explain how you get like angle and side angles?
So angle just means at least 2 of the angles are congruent. So in this one, 2 of the angles were congruent because this one here was like 46 or something like that, right? Is that what it was?
Yeah.
So 46 and 47 are not the same, and 44 and 43 were not the same, right? But only the 90s were the same. So we don't have at least 2 angles congruent. So you need 2 angles congruent in like the 2 triangles together. So you need 2 pairs of angles congruent. Okay? So that's angle. So side angle side similarity, you're looking at the included angle. So these are the 2 sides we know. So you see these are the 2 sides we know. So the angle that's formed by the 2 sides are 41 degrees. So the angle that is included is congruent, and the sides are in proportion. So 4 over 8 and 5 over 10 both simplify to 1 over 2, so the sides are in proportion with each other. Okay, does that make sense now? Okay. All right, determine whether the triangles are similar and explain your reason. So is triangle JKL similar to PMQ? So that means that it's JK over what? What would the ratio be? PM, okay, Brandon, what is it if it's KL? KL over?
MQ.
Good, and Lexi? JL over?
PQ.
Okay, so we only know sides in this one. Do you guys agree with that? Do you see how we know 3 sides? Everybody see that? So we can't use angle because we don't know any angles. We can't use side because we don't know any angles. So we're going to have to check for side, which means that all of those sides need to be in proportion with each other, meaning they have to simplify to the same number. So JK is 16, and PM is 12. KL is 8, and MQ is 9. And JL is 12, and PQ is 6, right? So if we were to simplify all of these, 16, 2, 3, 4 goes into both of them. So that is 4 over 3. 8 over 9 can't be simplified. And then that just simplifies to 2. Are those all in the same proportion to each other? So are these similar at all? No, they are not similar because sides are not proportional.
So if I want to find the proportion, I can just do like 16 divided by 12, take it as a decimal, turn it into a fraction, and then...
Okay, so quick thing here. You don't even have to turn it into a fraction if you want to. So if you're just checking for proportionality in these statements here, if you just wanted to divide all of them and get the decimals and just look at the decimals and see if they're all the same, completely fine. That's different than like finding the scale factor where it needs to be this. You're just literally using that number to say, are they the same? So it doesn't matter if it's a fraction or a decimal.
So if it's the scale factor, you have to have the fraction, but if it's that, it doesn't matter.
No, it does not if you're checking proportionality. All right. What is something else I know in this image? Tell me something else I know in this image. That we have vertical angles. So this angle is congruent to that angle. So, do we know two angles in both? Do we know two angles? I know one of these angles? No, so we don't have enough for angle. Do we know three sides? No, so we don't have side. Do we know one angle and at least two sides? Yes. Is that one angle congruent?
Yes.
So now we just have to check if the sides are in proportion with each other. So again, I'm looking at this similarity statement to do this. So it's TW over YW. Alana, what is WZ over? Good. And Paige, what is TZ over? Okay? And then we just substitute those numbers in. TZ and XY are not going to help us, so I'm just going to cross those off because there's no numbers on them. We don't care about that one. So TW is 10, YW is 20, WZ is 11 over 22. Those both simplify to 1 over 2. So are these triangles similar? Yes, they are side angle, side similar. The angles are congruent and the sides are proportional. Your Japanese pens?
Yeah, it's a white pen.
Okay, flip to the next page when you're ready. Are you okay over there? Corey, how's the game you're playing or whatever you're doing over there? That's good. Glad you're having fun. Hope you do well on the quiz on Friday, okay? I'm really concerned about you based on what you're doing right now, though.
What?
So we are going to identify the similar triangles and then find x. So we know that they are similar. So you know how we talked about similar polygons and how it might be nice to rotate them? So do you see how E and B are marked congruent? I'm going to rotate that second triangle there. So tell me, Dylan Keith, the similarity statement for these triangles then. The similarity statement is like the triangle what is similar to triangle what?
A, B, C
Not congruent, similar.
similar to D, F, E,
Be careful. Remember we rotated it for that reason.
or E, F.
There you go. E and B have the same marking here. Okay, so we do know that they are similar, so we don't have to check for that. So we can just set up our ratios here. So I have 4 over x, because they are both AC, and DF, which are my outside ones. BC is over EF, so that's 3 over, is that a 2? Yeah, not a Z. So 3 over 2. And DE and AB line up, so that would be 5 over 10/3. Okay, so we're finding x. What two would you like to set equal to each other for the proportion? What two would you like to set equal to each other, Brandon?
3 over 2 and 4 over x.
Why didn't you choose 5 over 10/3?
Because it's just more work you don't have to do.
Because you guys all love fractions so much, right? Yeah, I mean, obviously, if I had the choice of not using fractions versus using fractions, I would go for the one with the not fractions in it. Do you guys see that? So we cross multiply. So I have 4 times 2 equals 3x. So that's 8 equals 3x. So our x value is 8 over 3. I'm not going to write that as a decimal because that's a repeated decimal. Repeated decimals should not be written as rounded decimals. If it's something like 0.5 or 0.25, I don't mind because you didn't round it. Okay, if sides are parallel, you should look for what kind of angles?
Portions.
Madison, say that.
Alternate interior.
If lines are parallel, you look for alternate interior angles. We had angles and congruent, which both are true words. They are congruent angles. Specifically, they are alternate interior angles. So, Jordan, give me a set of alternate interior angles.
This is vertical. I'm like really lost right now.
Oh no, that's not good. Why aren't you saying anything? Guys, I don't get mad when you ask questions, do I?
Yeah, just kidding.
Oh, I was going to say.
Vertical angles.
We do have vertical angles. Do you really think I do? Melinda, do you think I do or no?
No.
Okay.
No, yeah.
Please, guys, if you are ever
You're nice
lost,
about it.
just stop me. I don't care. Okay, so Jordan, I'm going to go. Are you going to tell me you're lost?
Yeah.
Okay, yours is for a much different reason.
No, I just don't,
He's ready.
I don't understand how there would be alternate interior angles.
Okay, so you have parallel lines. So let me show you them. So the pink transversal is one of them. So Jordan, what would the alternate interior angles be with that transversal?
M and P and PRW.
What did you say, QRW? Yeah, okay, I was like, there's no Q, but you might have said the right thing and I heard the wrong thing. So our other transversal is the purple one. So with the purple transversal, what are my alternate interior angles for that one? Bless you, person. Bryce, what are my alternate interior angles with this purple transversal?
NMP and PWR.
So, okay, first of all, I want you guys to know why I'm doing this. This is not for a proof. This has nothing to do with that. This is so that you know which two triangles are similar. Because once you know that the angles are congruent, it's easier to line up the correct letters. Does that make sense? If you have the angles marked together. So you guys all understand why I did that. It's very similar to why I do this and I rotated it. So you guys see how I rotated this one here? The reason I did that is so that I know which letters correspond to each other to create the similarity statement. All right? So hopefully that helps you out a little bit with understanding that portion of it. Then we'll talk about this portion of it when I do that portion of it over there. So does that part make a little bit more sense to you guys, why we just did that? So what is my similarity statement, Bryce? What triangle is similar to what triangle?
Triangle NPM.
Okay, NPM is similar to what?
Similar to WPR. No, RPW.
Thank you. So N and R both have double dashes. P and P both have single dashes. And M and W both have triple dashes. That's why we found those alternate interior angles, so we knew which triangles were similar to each other to do the next step. So the next step is to find the side lengths. Side lengths in similar triangles or similar figures are proportional. So do you guys see how we set this up here? This part here? That's because side lengths are proportional. If their angles are congruent, but this is because they're proportional. So all I did is I took corresponding sides and put them into each of their own ratio and set them equal to each other. So we're going to do the same thing here with this one. So what are the ratios that I can create, Cameron, with this one? You're fine. We can do this. We need to be paying attention. I told you that. It's confusing stuff. Yeah, really, Corey? Mm-hmm. So Cameron, what are my corresponding sides in these triangles? Just look at these statements here. So if you're looking at 6, what does that correspond to in this other triangle? So 6 is on MP. So which one would that be? If this is 6, then that one is what? What's on that length? So we have 6 over x plus 4 equals, what's the other one then?
5 over 35.
Yeah, and it's important that you do the same triangles in the numerator and the same triangles in the denominator. So take a step back. Does that make sense so far? Is it making any more sense by slowing it down a little bit? Please, again, I don't mind if you say something. I'd rather you guys understand than me sit up here just talking to you guys without you understanding. Okay, so I put parentheses around x plus 4 because it is a binomial, so it's separated by addition or subtraction. I don't know why that lock is like that. Yes.
Why did you find so many of the things over there and only one on there? Like, see how that one has like 4 over x, 3 over 2?
Because I couldn't find the third one because there's no measurements on that side. Does that make sense?
Yeah.
Okay. And honestly, you don't need to find all of those. I was just showing you what all of them are. So we have 5 times x plus 4 equals 6 times 35. So this is very similar to what we did yesterday then. If you understood that. And we all know about that, so. Is it 38? Okay, so if I take a step back now, do example 3 and 4 make more sense now?
Yes.
Are you sure?
Sort of.
Sort of. Okay, I think we're still doing it on examples 5 and 6, so we'll continue this talk then, okay? And again, keep telling me what questions you have for me, okay? Did you guys, before I move on, did you guys understand how to use like the angle similar, side similar, and side similar, the previous examples? I'll go back a page for a second. Did you understand this page? Sort of.
Like, I get how, like, to find your answer, but I don't understand how to identify if it's angle, side.
Okay, so what I just do is kind of go through the checklist of the 3 things it could be. So like this one here, do you see how there's no angles marked in any of the triangles?
Yeah.
So I know it can't be either of these 2 things because they involve angles. Right, so that's why I can't do it. So it has to, if it's going to work, it's going to be side, side, side.
Oh, okay.
Okay, so then I just try to set up the proportional stuff for that and check it, and that didn't work, right, because the sides weren't proportional. For this one, I have 2 sides marked, so I can't use side, side, side because I need a third side, right? And I can't use angle, angle because I only have 1 angle marked. So it must be side, angle, side that I'm checking for.
Okay.
And that angle is the included angle, and it's congruent, and then we just set up the proportions and got the same thing. Does that make a little bit more sense? Okay. You're welcome. All right. What just happened? This is my last time, guys. It's because my sis decided to time out on me. Which one are you on? Examples 5 and 6? Okay. So identifying the similar triangles, then find x. So the first thing you'll notice is that we have angles marked. So I like to rotate them so that they're the same direction. You guys understand that? So I'm going to rotate triangle ABC so it's the same direction here. Looks the same size now that I've done this, but that wasn't intentional at all. So all I did is I rotated it. I basically redrew this one here. So I look at this one when I go to redraw it so I know what that looks like. And I'm just matching up. So the single and the single are A. The double and the double are Z and C. So that's why I got those letters here. So I know between A and B is 2x minus 3. And I know between B and C is 2. Okay. So do you guys see how I kind of redrew that so I don't have to, so it's easier to write the similarity statement? I don't really need that anymore. So Lexi, What is my similarity statement?
Triangle ABC is similar to XYZ.
So, A and X are singles, B and Y don't have anything, and C and Z have doubles. So that's why she lined those up. So that looks good. So what is the proportion that can be set up to find X? What is the proportion that can be set up to find X? Corresponding sides create a ratio, which is like a fraction, okay? So Hannah, go ahead.
6 over 2 equals x plus 1 over 2x minus 3.
So 6 over 2 equals x plus 1 over 2x minus 3. It's okay that they both have x's in the numerator and denominator. So you'll see here, what she did is she went from triangle Z, I'm just going to call it triangle Z, I know that's not its name, over this one, so she went to this one, so she did that again when she set up these corresponding sides to do the numerator and denominator. Since there's binomials, they're separated by addition or subtraction. We put parentheses, and now we can cross multiply. If you're confused by what I'm doing with my solving, please let me know. I'm just assuming you guys can solve by now. If I am wrong, I am sorry. Yeah.
How to do it?
So you divide 6 and 2, which is?
3.
So you'd say 3 equals x plus 1 over 2x minus 3. Okay. And then you'd multiply both sides by 2x minus 3, and you should be fine from there.
Can you just tell me after we do the rest of the notes? Can you pen?
Yeah. All right, so this wants us to identify the similar triangles, then solve for the indicated sides. So it says, given RS and UT are parallel, and then it gives us a whole bunch of other stuff. Let's first determine the similar triangles. So what angles are congruent here? Give me a set of angles that are congruent here. UQ and QS are not angles, those are segments. 3 letters. UQ, T, and yeah, so we have our vertical angles. Then we have our transversal here with our parallel lines. So our parallel lines are here. What are the 2 angles that are congruent? You only need 1 letter for these ones. What 2 angles are congruent because of that transversal? U and S. And because of the other transversal that's there, T and R. Okay, so give me, Dylan Daptula, the similarity statement for this one. And it's similar, just be careful with that because they're not the same size, right? So it's similar is what we say there. You're fine, I just want to make sure you guys understand it all. Okay, so then we're going to start labeling. So RS is 4. RQ is x plus 3. QT is 2x plus 10. UT is 10. And we're going to find the length of RQ and QT. So it doesn't want us just to find x. We're going to have to find x, but we have to actually find those lengths. So what proportion, Mariah, can we set up? RS is over what? Okay. More.
And R U
Over what?
over T.
Okay, so we can substitute in what we know now. RS is 4, UT is 10. RQ is x plus 3. And QT is 2x plus 10. I put the wrong thing in there. And then you're going to distribute. And set it equal to this. Okay, so multiply by the denominator. And that one, so multiply both sides in parentheses by 2x plus 10. Did you guys get x equals 5?
Yep.
So how are we going to find RQ then? Substitute 5 in. So RQ is x plus 3. 5 plus 3 is 8. QT is 2x plus 10, and we'll substitute 5 in there. So that is 10 plus 10, which is 20. So that will cancel. And then distribute 2/5 through that using your calculator. Sorry, this is the number 2/5. Distribute it through. Okay. And then you'll just have that distribution equals x plus 3. Okay? So distribute it, and then I'll go from there. Okay? All right. If it is it possible for triangle ABC and JKL to be similar? Explain your reasoning. So, I'm going to draw. We'll do it afterwards. I'll finish that one with you. Don't worry. And then just label them. So we're proving similarity. So what are our 3 options for proving similarity? Brandon?
Angle, side, side.
Which one could we use for this one? Landon?
Side angle side.
Yeah, we don't know 2 angles, so we can't use angle, angle. We don't know 3 sides, so we can't use side, 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 so we have to try side, angle, side. So if it's side, angle, side similar, the angle has to be congruent. Is the included angle congruent?
Yes.
So then we need to make sure the sides are in proportion with each other. So I do 10 over 60 equals 3 over 18, which is 1/6 over equals 1/6. So are these similar? Yep, they are side, angle, side similar. I think we have one more question. Finally. Only almost we're at 40 minutes of notes right now.
That's how my brain's fried.
Plus we had gone over homework for a long time too, so here we go. Are the triangles similar? Why or why not? So do you even see 2 triangles here? Okay, so if I redraw this, so you guys can see the two triangles. Do you guys notice they share angle A? So that's congruent, right? So AD is 5 and AE is 7. What is the length of AB? What is that? 15. And what is the length of AC? Yep, it's 7 plus 21. This one's 5 plus 10, so that is 28. So, if you're going to prove them congruent, which one of the similarity statements would it, or not congruent, sorry. If you're going to prove them similar, which one of the similarity statements would you have to use? Side angle side, right? We don't have two angles and we don't have three sides. So we know that the angle is congruent. So we do 5 over 15 equals 7 over 28, which is 1/3 and 1/4. Is that right?
So they're not similar?
So they are not similar. Let me just make sure I wrote everything right. Nope, so they are not similar. Sides are not proportional.